Hello everybody and welcome to our webinar today. My name is Deborah Berry and I work in the Medical Affairs Department at Medela as educator and Medical Affairs Manager. On behalf of EMBA and Medela, we'd like to thank you today for joining us, and we're really delighted to present this topic today, which is around human milk, hints to increase its utilization in the neonatal period. I will be your moderator for today. For the next 1.5 hours, we are delighted to bring you 3 speakers who have real expertise in their topics. So I really do hope that you enjoy the webinar, you learn a lot. And before we start, I will firstly hand you over to Enrico Bettino. Enrico is the past president of EMBA, and he will give you a short introduction. Thank you, Enrico. Over to you.
Yes. Welcome to everybody. Do you see me? I don't know, maybe. On behalf of EMBA, I think that almost all of you will know what is EMBA. EMBA was established in 2010 in Milan, and it is an European association aimed to promote the activities of human milk banks in Europe, to operate their collaboration, but also to promote the use of donor, but of mothers' own milk, in particular for preterm infants in neonatal intensive care. I want only to say that everybody is welcome to join EMBA, everybody who is involved in this issue related to neonatal nutrition. This is a common goal also with Medela, and this common goal prompted us to organize this webinar, whose title is Hints to Increase Utilization in the Neonatal Period and in Critical Newborns of Human Milk. So, I have to stop. I give again floor to Deborah. Thank you again to, first of all, to Medela for the support and the organization of this webinar. Please, Deborah.
Thank you very much, Professor. Yes, well, I'd like to now give the word very quickly to Natasha Jaloux. Natasha is head of our global medical affairs team here in Medela Europe, who would also like to welcome you all and give you a short introduction. So Natasha, over to you.
Thank you, Debbie. Yes, good afternoon, everybody. My name is Natasha Jaloux. I am responsible for Medical Affairs Europe at Medela. And we are really very happy to welcome you to this first EMBA webinar, which we are delighted to support. At Medela, we are focused on turning science into care to nurture health for generations through 3 activities highlighted in our mission statement. Advancing research, especially in human milk and lactation, observing natural behavior, in particular of mothers and infants, listening to you, to our customers. With this webinar today, we all contribute inch by inch to improve the nutrition with human milk in Europe and even internationally, as we have today guests from overseas, I think from Quebec, from Canada. So thank you for being here today. I wish you a very interesting webinar.
Thank you, Natasha. Thank you very much. If we could just have the next slide, I'll just go through some very quick housekeeping. For those of you who aren't particularly familiar with GoToWebinar, if you have any questions for the speakers, please enter your questions by using the questions area, which you'll find in the dashboard. We'll try and answer as many questions as possible at the end of each talk. So there will be, each talk will be 20 minutes and then we'll have 5 to 10 minutes for questions to the speakers. So please be as interactive as possible. We're really keen to hear what your thoughts are and your questions are. If you have any questions around technical or organization in particular, they can be answered at any time, again, by typing in the questions part. And we can go to the next slide. So yes, I am really delighted today to introduce our very first speaker, Dr. Daniela Much. And Daniela Much, PhD, is also qualified as an IBCLC, and she is scientific manager here at Medela Europe since 2018. Before joining Medela, Daniela was study coordinator and researcher at the Technical University Munich and Helmholtz Center Munich, and she has 10 years experience in clinical trials in breastfeeding and lactating women and their infants. So a lot of experience here today on the call. Daniela's areas of research interest include the importance of effective lactation initiation in high-risk populations, and also proactive management of lactation care of mothers with preterm infants using a quality initiative approach. Dr. Much has also published her work in several peer-reviewed journals. And for those of you who haven't seen her on the speaker arena, Daniela also speaks nationally and internationally on the topic of all things lactation. So today, Daniela is speaking particularly on early intervention to support human milk feeding in the NICU, a quality improvement initiative, and I'm delighted to hand over to Dr. Much to explore this topic in more detail. Over to you, Daniela.
Thank you very much, Debbie, for this kind introduction. And today I will be speaking about the importance of effective initiation of lactation in mothers giving birth to preterm infants. And I want to talk to you during this this EMBA and Medela webinar series, because protecting milk supply and breastfeeding is really a shared responsibility. So today you will learn more about lactation physiology and how lactation physiology informs best practice for lactation initiation. So here are my disclosures. Since I'm an employee at Medela, I obviously have a material conflict of interest. However, Medela is really delighted to be a co-sponsor and co-organizer of this scientific event. So let's start this presentation by looking at what we are trying to achieve. Our objective, of course, is that all mothers achieve their breastfeeding goals and have successful lactation. However, not all situations are the same. There are those 50% of mothers who breastfeed their infant without any challenges and who do not need any help. And there are those mothers who need some sort of help because of breastfeeding issues. And then there is this other extreme, around 10 to 15% of mothers whose infants cannot go to the breast due to illness or prematurity. And these are the mothers I would like to focus on today. And by knowing how lactation physiology works, we can intervene timely and appropriately so that all mothers achieve their lactation goals. So in order to help mothers initiate and build their supply when necessary, we need to identify mothers with risk factors for lactation. And there are antenatal and postnatal risk factors that can be assessed. Many of these we cannot control, such as maternal age, diabetes, obesity, or even premature birth. But what I'm going to focus on today is factors that we can influence as clinicians. And this is the timing and the quality of milk expression, particularly in high-risk populations, such as mothers of preterm infants. And if you consider that on average, a mother delivering a preterm infant who requires a stay in the NICU has many of these risk factors, it really becomes clear why these women are at higher risk for lactation failure, and that best practice methods should be used from as early as possible to assist these women. So what do we mean when we talk about initiation of lactation? So the very first area to focus on are the textbook definitions. In the past, initiation of lactation was described as lactogenesis 1 and lactogenesis 2. However, since the word genesis means the beginning, it was a bit counterintuitive to have lactation begin twice. So now the terms lactogenesis 1 and 2 have been replaced by terms that really provide a functional description what is happening at the physiological level. So lactation begins with secretory differentiation, previously known as lactogenesis 1, and this is the period during pregnancy when the mammary epithelial cells differentiate into lactocytes. So this is the phase when the breast generates a population of milk-building cells. This is followed by secretory activation, previously known as lactogenesis 1, and this is the initiation of coipus and rich milk production. So let's have a closer look at this two-part process, which is the initiation of lactation. So during secretory activation, the alveolar epithelial cells differentiate into lactocytes, and this involves significant mammary growth and development. So the women really already during pregnancy experience that their breast tissue develops and grows. In the second half of pregnancy, these differentiated lactocytes are able to synthesize milk components in the form of colostrum. However, only small volumes of colostrum may be produced. So because the majority of milk components is still excreted in the urine of the mother, because the lactocytes and the junctions between the lactocytes are still very leaky. We will come to this point later in time. What's important to know, especially for mothers who deliver a preterm infant, is that this differentiation process also continues after birth. And this is particularly relevant in preterm delivery because those mothers did not have the entire duration of pregnancy to develop their mammary glands. So after birth, the breast then shifts gradually into secretory activation, the second phase of initiation of lactation. This shift approximately occurs after around 72 hours postpartum after term delivery, or it can take longer. During this phase, the mammary gland cells that were generated during secretory differentiation are then switched on and activated to start making breast milk. So this phase is usually related to a dramatic increase in milk production and is often referred to as having the milk come in. What's really important to know is that the initiation of coipus milk secretion nearly always occurs after birth. And this is regardless whether the milk is removed or not, whether the breast is stimulated by breastfeeding or not. So it's not reliant on milk removal. However, it can be influenced. So secretory activation can be late in moms with risk factors, but we can also see earlier secretory activation, earlier onset, if lactation best practice are applied. So understanding the physiology of lactation is important, because knowing how the process works will help us and empower us to know when and how to intervene. So what happens after birth? There is this really critical period for the onset of lactation. So during pregnancy, the hormone progesterone blocks corpus milk production. But after delivery of the placenta, the levels of progesterone begin to drop. And with these falling progesterone levels then allow the hormone prolactin, the milk-making hormone, to kick in, so more milk production can occur. And with proper stimulation, the breast tissue already developed during pregnancy goes on to switch or activate the milk production. And now I ask you, what's the right stimulation? It's of course suckling, because the gold standard is the infant. And each suckle at the breast induces a surge or peak of prolactin to signal milk production. And this initial phase after birth and before secretory activation is really a critical period for future success. And it is this phase where the breast must receive sufficient stimulation. Long-term challenges in milk supply really originate and stem from these early days. So what happens when milk comes in? So triggered by the hormonal changes I mentioned before, there are key events taking place in the lactocytes in the milk-making cells during secretory activation. And here you have a screenshot of a lactocyte. Initially, when the baby is born, the spaces between the cells are quite large. There are still gaps between the lactocytes in the breast. And large volumes of milk cannot be made or maintained in the lumen of the alveoli. A key reason for that is that lactose, the breast milk sugar, which is produced by the lactocytes, can move freely between the alveolar lumen and the capillary blood supply. However, during secretory activations, these spaces begin to close, and this is catalyzed by the hormone prolactin. It catalyzes tight junction closure. So when these spaces between the cells are closed, the lactose can no longer move freely between the alveolar lumen and the capillary blood supply. So lactose in the lumen then functions as osmotic regulator and attracts water into the lumen so that large milk volumes can be produced. And these are the cellular events that are taking place throughout the first hours and days after birth and really underpin the transition from few drops of colostrum to corpus milk secretion. And this transition is known as milk coming in or secretory activation. And when we again look at prolactin, it really catalyzes this closure of tight junctions and is critical to continue high concentrations of prolactin in this early stage, because suboptimal and low concentrations will jeopardize milk production. Thus, early, frequent, and effective breast stimulation in these early days are really key to optimize breast programming. So something that I consider really important is that given the fact that progesterone blocks corpus milk secretion during pregnancy, it's really physiologically normal not to have milk in the first few days. So mothers should be made aware of this fact so they do not think that they are unable to breastfeed if they do not have milk after 24 or 48 hours. So as clinicians, you have to really reassure moms that drops or nothing at the start is really normal. The purpose is not to make milk, but to program the breast for long-term supply. So having milk come in a timely manner is really a key for successful lactation start and long-term breastfeeding. And as I mentioned before, secretory activation normally occurs between 24 to 72 hours postpartum. Very subjectively, the mothers experience a feeling of breast fullness, breast tenderness, breast engorgement. Some may also report leaking. And also the mood of these women changes. So some mothers may feel emotionally very fragile and tearful, also anxious. And this is because the pregnancy hormones decrease. Milk coming in after 72 hours after birth is considered delayed. So now, why is this important? Delayed secretory activation has been consistently associated with negative breastfeeding outcomes in the scientific literature. In the short term, it reduces the risk for excessive neonatal weight loss, suboptimal breastfeeding behavior in the first week, and increased formula use. And in the long term, we have higher risk for reduced breastfeeding duration. And mothers really indeed with delayed secretory activation have 60% higher odds of stopping breastfeeding at 4 weeks. So that is why timely interventions to avoid a delay in secretory activation are critical. So what can we now do for mothers whose infants cannot go to the breast? We need to remember what our gold standard is. And the gold standard is the healthy term baby, healthy mother diet, where the baby goes to the breast within the first hour after birth and breastfeeds and during skin-to-skin contact every 2 to 3 hours. In mothers with a premature baby, where the baby is not able to stimulate the breast early and often, we need to intervene. And we need to intervene in a way that mimics what the baby should be doing. And this is to stimulate the breast by suckling. Remember, when a baby suckles, we have suckling-induced prolactin concentrations, so-called peaks, and they are highest soon after delivery. Thus, early, frequent, and effective expression are really critical to achieve the prolactin levels for optimal breast programming. So the interventions that we can now carry out as clinicians are the following. Hospitals should incorporate policies and protocols that identify mothers who have risk factors. This enables us to proactively work together with the parents to prevent lactation delay. And what's of course critical is parental education and early support. Parental discussions should also navigate around the timing of the first pump. Optimally initiate pumping within the first 3 hours after birth to provide effective breast stimulation when infants are not able to feed. And advise frequent pumping, which is 8 or more pumping sessions in 24 hours. What is also really vital is to ensure at least one session during the night so that there are no longer than 5 hours between the sessions. This is of crucial importance because the group around Donna Geddes at Western University Australia has shown that if the gaps are longer than 5 hours, we see changes in tight junctions. They become again leaky. So that's why it's crucial to wake parents and inform them about this process. Also, tracking pump volumes is quite important. We should track the average time to onset of secretory activation in pump-dependent mothers. And we speak about secretory activation in pump-dependent mothers when they have 3 consecutive pumping sessions and have gained more than 20 milliliters per session. So 20 mil, 20 mil, 20 mil combined from both breasts. And then we have secretory activation in pump-dependent mothers. And of course, hospitals should facilitate and give possibilities for skin-to-skin contact, optimally zero separation policy. Skin-to-skin offers early opportunities for non-nutritive suckling, which again is perfect breast stimulation. And this results in longer and more exclusive breastfeeding. So we talked about early and frequent expression. Now let's look at the evidence for effective expression. As one part of effective expression, double pumping is standard of care for mothers whose babies cannot go to the breast. All mothers, therefore, should have this discussion with their healthcare professionals about the benefits to pump both breasts at once. This is because double pumping stimulates in the initiation stage the breast, of course, and once milk is available, double pumping generates more milk per pumping sessions. So moms who double pump see up to 80% higher milk volumes per pumping sessions in the long term. And this is really vital for preterm infant. After double pumping, milk also has higher fat content, which means more calories for the preterm infant. And higher fat content is also important in terms of brain development because we give these infants the essential fatty acids they need. Double pumping is also twice as fast. Mothers get more rest and they have more time for skin-to-skin contact with their preterm infants, which is a very important breastfeeding supportive practice. And overall, with the help of double pumping, moms are also more likely to achieve 8 or more pumping sessions in a 24-hour period. All these interventions are really carried out to help mothers of preterm infants maximize the number of differentiated and activated lactocytes in their breast to maximize their production capability, so maximize their milk volumes. And what is also very important to be aware of, that there is a strong vulnerability of lactation initiation in the first 2 weeks. Rebecca Hoban and her group have published around this, and she showed that mothers whose milk had come in, so mothers of very low birth weight infants whose milk had come in, and their pumping decreased for only 1 day in the first 2 weeks, immediately showed changes in milk sodium. Milk sodium is a biomarker for lactation initiation, and when milk sodium rises, this indicates leaky cellular junctions, and this is risking milk supply. We want the moment to express frequently that milk sodium drops and the cellular junctions are closed. What's also important, from around 14 days postpartum, we are likely to see that milk production volumes become more constant and more stable. And from this point onwards, it can be very difficult for a mother of a preterm infant to increase her milk supply significantly. And you know the discussions, how frustrating that this can be for the mothers. So we really have limited time to act. And this is why coming to volume is also so important. The group around Hoban has also published around this concept. So what is coming to volume? Coming to volume is it indicates that milk supply is on track to meet the infant's long-term needs. It's defined as expressing more than 500 milliliters by day 14. And it has really been shown to be the strongest predictor of mother's own milk feeding at NICU discharge. So it actually gives these women around 10 times greater odds of feeding mother's own milk at discharge. So we should support all mothers to achieve this goal in case of pump dependency. So before I close my talk, I want to share kind of a best practice pathway or checklist for effective initiation of lactation. Parental education plays really a critical role here, as it is decisive that families know about the value of own mother's milk to infant health outcomes and the time-sensitive nature of lactation initiation. Parents should get clear, evidence-based instructions, also to set their expectations. So discussions with parents should navigate around the timing of first pump. This is really vital to initiate early pumping within the first 3, at latest 6 hours after birth, and to stimulate both breasts at the same time. It's also very important to ensure that parents express 8 or more times in 24 hours, especially for the first 14 days, and ensuring at least one session during the night to prevent tight junction changes. Proactive lactation consults, of course, are ideal, and using pumping logs to track, but also to monitor milk volumes for the first 14 days. And of course, we should also monitor what the infants are feeding and track the amount of own mother's milk delivered to the infants in the neonatal period. But I'm sure that the next speaker, Tanya, will stress this a lot more than me. So it's really necessary to provide clear and consistent information to the mother and the parents, and this will give the families the opportunity to make an informed decision. So prioritizing initiation and building an adequate milk supply is really the most important lactation-related responsibility, not only for the NICU, but also for the maternity caregivers. And there needs to be the sense of urgency, because the long-term supply challenges you see after 4-6 weeks really stem from these earliest days of lactation. Lactation initiation relies on early, frequent, and effective breast stimulation, and if the baby can't do all 3 on day 1, which is almost always the case in preterm infants, pumping is really required right away. So early support really sets families up to meet and also choose their lactation goals and to choose their breastfeeding duration, because this really should not be limited by milk supply issues. So with this, I would like to close my talk. And now if there are any questions, I'll be happy to try and answer them for you.
Thank you very much, Dr. Muth. That was a really interesting presentation. Yes, we have a couple of questions. We have just enough time for a couple of questions. One from the audience who is wondering about hand expression and wanted you to comment on this with regards to that it is common practice, I guess, in a lot of hospitals. Do you have any thoughts around that in terms of the research?
Yeah, so there's of course research also around hand expression and also randomized controlled trials who have compared the effectiveness of hand expression versus pumping. And I think this really a fantastic questions, because indeed we see this in a lot of NICUs that, for example, hand expression is used in the first 24, 36 hours. So my view on that, in a pump-dependent population, hand expression alone should really not be used routinely during this critical window of lactation initiation. It is perfectly helpful to get out the sticky colostrum, but hand expression really should be combined with pumping. So why is that? When you look at the physiological level, it all comes down to prolactin. So when we go back to the infant as our gold standard, what's the infant doing? When infants breastfeed, they use suction and compression and to remove milk, and they release prolactin and oxytocin. A breast pump uses suction but has no compression. Hand expression has only compression but no suction. But it's suction that really releases the prolactin, which again does all of these really important things for breast programming I mentioned. So the closure of the tight junctions. Prolactin also prevents apoptosis of milk-making cells. It upregulates genes that upregulate more milk, and make more milk making cells. So what's important, unless we have suction, we do not have prolactin and we do not have breast programming. And this has been shown by 2 randomized controlled trials also. I think it was Tina Slusher and then the other one, Marie Lucier, in 2015. They were both concluding that hand expression is significantly less effective than electric pumping in mothers of very preterm infants. And the Morton studies showed that hand expression as an adjunct method, so in combination with pumping, really appears to be beneficial and may help increase milk production. So our recommendation is to use both techniques. Either way, neither the pump nor hand expression perfectly imitate the baby. So please use the pump in combination with hand expression for optimal early initiation of lactation.
Thank you very much.
There was a lot.
Thank you very much, Dr. Much. Yes, it's a complex question, but thank you for that answer. We have time for one very quick question. Is there a possibility to stimulate the breast before delivery? Do you know what the research suggests?
Yes, this research mainly comes from the field of diabetes, which was my postdoc research topic. In Australia, there was performed a randomized controlled trial in diabetic women who hand expressed before delivery. And the main aim was to see if that practice was safe or if it induces preterm delivery. And what I remember from this research is that in the end it was safe. So there were no infants who had to go to the NICU because of preterm delivery. However, it was not effective for milk volumes after birth. So this is, of course, limited to the population of diabetic mothers, but I know it's very common practice, at least here in many German hospitals, that if there is expected preterm delivery and mom has a scheduled cesarean, that they hand express small drops of colostrum, and this is then used for oral therapy of the preterm infant directly after birth.
Okay. Thank you very much for answering that question so concisely. Okay, now we're going to move on to our next speaker. Thank you very much, Daniela. And before I introduce our next formal speaker, I just want to give a small word to Dr. Rosalina Barroso, who was going to speak for us today, but she's on the webinar, but she's had an accident, so isn't feeling 100%. But I wanted to introduce Professor Barroso, who is the head of the neonatal intensive care unit at Prof. Dr. Fernando Fonseca Hospital in Portugal, and has over 20 years of clinical experience in neonatology. As president of the Neonatal Portuguese Society from 2013 until 2016, and her areas of research interest include nutrition and infection and the link between the two. And Dr. Barroso has also received some awards for her outstanding work in neonatology. We are welcoming Professor Barroso today. She is here to support her colleague, Dr. Tanya Marquez, who is our speaker today on our next topic, which is increasing the dose of mother's own milk in the NICU, a quality improvement approach. Dr. Marquez, you are also a neonatologist in the same hospital. Welcome to the webinar, and you work in a level 3 medical surgical unit, is that right, in Portugal? And your level of expertise include nutrition, ventilation, palliative care, and neonatal pain. So a big expanse of interesting topics there, I have to say. And you're also involved in the quality improvement project within your NICU with the goal to improve human milk feeding, right? And you also have 2 postgraduate degrees in neurodevelopment and palliative care. And you have 2 clinical trials and research projects ongoing, as well as 14 published articles. So welcome, I give you the floor. Thank you very much.
Thank you, Deborah. As you all can see, my name is Tanya Marks. I'm replacing Dr. Rosalina, and I'm from the team of the quality improvement, and I'm going to speak a little bit of how it was our project. This is the summary of my presentation, and just to I need to say that this project was supported by Medela, supplying the NICU with extraction pumps. Mother's own milk is, as we all know, is the food of choice of all infants, and especially premature. And standard practice in neonatal units should be to promote it. The unique composition of the human milk, especially the mother's own milk, it reduces the risk of many comorbidities, including retinopathy, necrotizating enterocolitis, late sepsis onset, and respiratory illness, and a shorter left stay. And as Daniela told, mothers of very low birth weight must overcome significant barriers to succeed with breastfeeding. And this, first of all, we have the separation from their infants after birth. And another point is they have usually the delay of initiation of milk expression. they have a stressful environment of the NICU, and lack of knowledge of the benefits of the human milk, human milk. And health professionals don't adequately train and assist these mothers. And we know that quality improvement initiatives have been shown to be effective in increasing the amount of human milk and improving breastfeeding in hospitalized infants. And for that, with the Medela support, we had implemented our quality improvement project to increase the use of mothers on milk in the NICU. Well, Fernando Fonseca Hospital is a general public hospital covering the Lisbon metropolitan area with a tertiary referral center. And this population is multicultural and around 50 immigrants, and we have a significant portion of low social economic groups. We are a baby-friendly hospital since 2010, and we have 3,000 deliveries per year, around 10% of premature. The NICU is a medical surgical level 3 with 20 beds. We admit 350 newborns per year, 20 to 25% extreme very low birth weight. Our care is central in the family, and we promote the breast milk and skin to care, and we have protocols that promotes neurodevelopment. And this project started in March in 2019 after a symposium in London, after the Medela Symposium in London. First of all, we have initial consultation with assessment with the NICU scorecard. And this scorecard have two parts, a mother and infant scorecards. And accessing the mother scorecard, what we saw that we encourage to express early and often, but we didn't have any specific education, no protocols, and no metrics. And accessing the infant scorecards, we saw that we were aware of most practices. We did kangaroo mother care in policy. We measured the breastfeeding rates, but we didn't measure the breastfeeding expression, and feeding logs define composition and volume, and we didn't have no metrics. And in the end of the assessment, after the assessment, we decided to focus the project in two things: coming to volume and increase the dose of own mother's milk. Well, as I told before, we improved. The goals established was improve coming to volume. And this, as Daniela say, at least at the 40 days, we have at least 500 milliliters per day of own mother's milk, and improve on mother's milk feeding for very low birth weight infants, more than 50 milliliters per day. Well, we started to establish a core search team, including neonatologists. Our team includes neonatology, the nurse from the units, from the delivery ward, and from the maternity. We have also a physiotherapist. And the inclusion criteria was newborns admitted in our NICU with a length of stay more than 14 days. And the exclusion criteria was, as you can imagine, the length of stay less than 40 days, and any kind of contradiction of on mother's milk. And if the child born outside our hospital. The defined success was early, frequent, and effective expression can improve coming to volume and subsequent a dose of own mother's milk. And early, we consider the extraction until waiting the 6 hours after the delivery. But our goal, our aim, is the first 3 hours after the labor. And frequently, at least 8 times for around the clock. And we always talk this 2 and 3 times each hour. And effective expression was double pumping, as Daniela told, that increase the milk. Well, initially, the project only have 2 phases. The first one, it was the baseline, and this baseline served to demonstrate the current status of on mother's milk doses in the NICU. We did a retrospective analysis between July and September 2019, and what we did with we extract the data for each infant, each infant each day, and in addition we evaluate the composition of daily feeds, and we record. And the other phase was the intervention ones, and we did a lot of things. Okay, first of all, we trained the healthcare profession in the NICU, medicals, nurse, and the nurse from the maternity and delivery were, and we increased the numbers of the pumps. Here we have the support of the Medela, and we did a lot of protocol of early, frequent, and effective expression. And we did leaflet, 2 leaflets and a video. And we formed decision with NICU talking points. The data analysis, we enter in offline data collection tool from Medela, and then we exported that data to describe analysis in Excel. Well, as you can see, this is the first leaflet that we did. This is in Portuguese, but this congratulates the parents and inform the benefits of the milk especially the own mother's milk. As you can see, this is have a QR code. And the another leaflet explains how to use the breast pump and how to turn on and turn off. And this have also a QR code. We did a video to demonstrate step by step how to use the machine. And I'm going to pass a little bit here. Can you hear it? Hello, can you hear it? Ah, okay.
There isn't any sound, but we can see the video okay.
Okay. Don't you have the sound now? Let me see. Can you hear it?
No.
Oh. Well. I'll move on. Okay, this is the video and the QR codes. If the parents have any difficulty, they could see it by doing the download and see it in by the phone. Okay. Oh, sorry. Okay, this demonstrates the two programs that the machine have. Oh, sorry. And how to put. Okay. I'm having technical problems.
Hi, maybe the technical team can support.
Sorry.
Please, that's okay.
Well. Okay. Okay. Thank you.
You're welcome.
I think now, yeah. And this shows the quality improvement timeline. And as coincidentally, when we started this project, COVID-19 pandemic impact all over the world and also in our project. And for better understanding, we split this project in 4 phases. The first phases that I just spoke about is the baseline without any intervention. The phase 2 was the intervention one, and the phase 3 and phase 4 is when in the pandemic COVID-19. The first one is the phase 3 when COVID hits Portugal in April to September 2020, and with severe restrictions and all over the place, including the NACO. And the phase 4 is since October 2020 and June 2021. And since in the middle here in the February, we started to reduce the restrictions. Well, what we saw in COVID-19 impact negatively our project, because in phase 3 there were early postpartum discharge of all mothers, including very low birth weights. And we restrict parent visits in the unit. The mother only could stay 6 hours there. We have a lack of breast pumps for home use. We reduced the costs, and we separate the staff between COVID-19 infected and non-infected mothers and babies, and we saw an increasing nursing workload. Well, and in phase 4, the NICO started to have no restriction for the mothers, and the fathers could visit every other day, and we started to have breast pumps for home use. This is our results. We have a total of 187 infants in all. We have different numbers of infants in all phases, but the mean gestational age was similar. It was 31, and the birth weight was of extreme and very low birth weights was similar in phase 1 and phase 2, but in phase 3 and phase 4, the COVID-19 pandemic, we saw a rising number of the infants very extreme and very low birth weights, more than 60%. We don't know the reason, the explanation for that, but we might speculate that it must have something to do with the pandemic and the COVID disease. Well, time to first expression. We split in 4 phases, and the first one is the two groups. We design early expression until the 6 hours, and we can see here that in phase 2 and 4 we achieve a goal that we have mothers to first expression in this time, in this hour. But as you can see in phase 3, we didn't have any women to do the first expression and early expression, and most of them only take the first expression after the 12 hours. And the expression frequency, as you can see here, in the first day, the phase 2 and phase 4, the median of frequency were 3, and at day 7 we increased from 4 to a half. And in COVID, in the phase 3, you can see we decrease the number of expression to 1.3, but in but at 7 day we could increase this number to 3.5 times. As the daily maternal expression volume is related with the frequency, you can see there we have more volume in the phase 2 and phase 4 and less than the phase 3. This table, this figure represents the frequency and the milk volume at day 7 by month, and you can see that in phase 2 we increase this frequency in milk, and then when started COVID it goes down, and until the phase 4 when started to relieve some restriction, and we could lower this volume inclusive more than we have did in a phase 2. Well, the composition of feed. Remember that I spoke, the phase 1 was the baseline, and the baseline we wanted to see which to demonstrate the current states of on-mother milk doses, and we and the results of very low birth weights on mother's milk, it was very disappointed because we didn't have more than 50 milliliters per kilo per day in this. And with that, you can see and this graph down, the yellow, it's the on mother's milk. And in the phase 2, as you can see, we rise this amount, fortunately, this amount of milk, especially in this very low birth weight. As you have lots of yellow in the figure. And well, in the phase 3, it was bad for so in the first day, but even in this phase 3, we could we reach some very low birth weight, reach the goal of more 50 kilo per day in 35%. And in phase 4, with the relief of restriction, we started again to reunite the team and to improve our focus in this. And as you can see, we increased lots of human milk, mother's milk, in this in very low birth weight. And if you notice, in the first in the first and the second day, we have almost 100% or more than 90%. Well, and our results, we increased on mother's milk in the first 40 days and in very low birth weight. And for finishing, we increase of the increase of newborn feed with we increase the newborn feeds of on mother's milk. We now thankfully we have better lactation practices in the NICU, and I would like to thank the support of Medela. It was very important, and for that we are doing better with our infants. And you have an infancy of data resistor. We need to improve this. We are trying to improve now, and as I think it's all, I think this is transversal, that COVID-19 impact negatively in this project. Well, and the next steps is we need to incur the time for the first expression until the 3 hours after delivery, and increase the number of the expression. And we need to improve the records. When we started the project, it was the nurse that records the breastfeeding, and then it was the mothers, and the records were not very good. And now we are evaluating and comparing the data from the last year. And for the end, I would like to thank my team and the support of Medela, and thank you for your attention.
Thank you very much, Dr. Marquis. We don't have time for questions. Unfortunately, we've run just a little bit over. That's okay. So we'll move on, and maybe we can make up some time at the end, but we'll see. But thank you very much for your insights, and we look forward to maybe seeing a publication on those results at some point. I want to move swiftly on now to introduce our final speaker of the afternoon, Dr. Chiara Tabasso, who is a nutritional biologist working for many years in the Donor Human Milk Bank in Milan, in Italy. And yes, a really interesting biography, I have to say. Thank you for sharing. And you're involved in analysis of donor milk, donor screening, and you have many research activities focused on donor milk, inoculation and personalization of donor milk. So without further ado, I will hand over to you for an informative talk. Thank you very much, Dr. Tabasso. Hello? Dr. Tabasso, would you like to start? Can you hear me?
Hello, do you hear me?
Hello, yes, we can hear you now, yes.
Hello, do you hear me?
Yes, we can hear you. That's fine, thank you. Yes.
Okay.
Over to you, thank you.
Okay. Thank you, Deborah, for your kind presentation. I can see my slide. Just a moment. Okay. Sorry, but my slides doesn't work. Okay. Okay. Thank you, Deborah, for your kind presentation, and good afternoon, everybody. Now I'm going to talk about donor human milk and microbiota and its possible strategies to personalize it, especially through mother-owned milk. Okay. We all know that historically human milk has always been considered, I'm sorry, but slide doesn't work. Okay, I was saying we all know that historically human milk has always been considered sterile, but now it's currently recognized as a living ecosystem consisting of a wide range of microorganisms. So not only macro and micronutrients, but also bioactive compounds and microorganisms. Thus, for this reason, human milk represents a unique food, and it is the gold standard for the infant feeding, especially for preterm infants. Several scientific evidences have confirmed the importance and the health benefits of human milk, both for preterm and term infants. For example, it decreases the risk to develop NAC. It reduces the rate of lower respiratory infection, and it also promotes brain development. So during this time together, we will briefly talk about what makes up the microbiome, its origins, and its functions. And finally, we will focus our attention on how to implement and personalize it. So first, what about its composition? When we talk about human microbiome, we only think to bacteria. Surely bacteria represent a predominant part of microorganisms, but we also find viruses, fungi, and yeast. Generally, Streptococcus and Staphylococcus are the predominant genera, which are followed by Bifidus, Lactobacillus, and others. Some studies established the existence of two different cores, which has been hypothesized. And then talking about the origins of the microbiome of human milk, we can say that the origin of human milk is a complex and dynamic process which is not fully understood. There are different and not mutually exclusive origins suggested for the human milk microbiome. First, the origin from the oral cavity of the newborn. So as a consequence of a transfer of microorganism from the oral cavity to the mammary gland. Secondary, a second feasible origin is in the maternal skin. I mean, the main skin commensal microorganism colonize the mammary gland throughout the nipple. And third hypothesis origin is that of the maternal gastrointestinal tract. So from here, microorganisms reach the mammary gland, so throughout the entero-mammary pathway. But what about factors influencing the human milk microorganisms? Microbiota, sorry. Factors affecting human milk microbiota can be grouped in 4 macro areas, which are maternal, I mean diet, lifestyle of the mother, the mode of delivery, BMI, and also antibiotics during the delivery period. Neonatal factor as birth weight, gestational age, and gender. Environmental factors such as geographical location, collection method, and also seasonality. Human milk-related factors such as pasteurization, stage of lactation, and milk manipulation. So all these factors are responsible of an high inter-individual variability of microbial species in human milk microbiome. And the human milk microbiome seems to be able to influence the health of the newborn, both in the present and in later life. It seems to be shaping the microbiome of the infant at the gastrointestinal tract. And as you can see in this slide, an infant gut microbiota characterized by a lower microbial diversity, together with a prevalence of bifidobacterium and lactobacillus, seems to lead to a lower risk of dysbiosis, and thus resulting in a healthy status microbiota, which is related to a balanced microbiota. On the other hand, an high microbial diversity at the level of infant gut microbiota, with an abundance of Bacteroides, Clostridium, and coli, and together with a lower bifidobacterium species, increase the risk of dysbiosis, which potentially lead to allergy, obesity, and a series of conditions of unbalanced microbiota. As we all know, the American Academy of Pediatrics recommends the use of donor human milk for feeding preterm infants when the mother of milk is not available or insufficient. But donor human milk, before to be administered, had to be subjected to several processes and manipulation steps, which are known to affect not only the macronutrient content of donor human milk, but also obviously is microbiota. In this slide, I show this slide because I would like to fully represent the Milky Way of the nation. And I would like to focus your attention on some of the key points throughout this flow, which are key points in terms of human milk microbiota. First step was the milk collection, which generally was performed at donor's home. Then the storage of the milk collected, which is stored in the freezer at donor's home. The process of pasteurization, which is a thermic treatment which inactivate the microbial communities in human milk, and also freezing storage in human milk banks. In this slide, are shown the effect of milk banking procedures in terms of donor human milk composition. And here on the right, you can see that when an infant in NICU is directly breastfed, no loss of nutrients and bioactive compounds is revealed, and also of microbiota. But on the other hand, we can see the longer trip of donor human milk. Donor human milk, which is previously expressed in plastic container, then it is frozen, thawed, pooled, older pasteurized, refrozen, rethawed, and then fortified to be administered. And pasteurization, which is a mandatory step in human milk bank, not only lead to a reduction of bioactive compounds and macronutrient content, but also inactivate the bacterial count. In this recent study, the effect of pasteurization on the microbiota of 32 fresh breast milk sample is shown. And we can see how the pasteurized milk and the fresh milk present a bacterial diversity. The pasteurization, after pasteurization, the most represented taxa, before the pasteurization, the most represented taxa in fresh milk is are proteobacteria, followed by firmicutes, and less abundantly by actinobacteria and Bacteroides. And after pasteurization process, we can see the presence of some thermoduric bacteria, which are able to resist to the pasteurization temperatures. In this study, instead, it's shown how the microbiome of the infants, so the gut microbiome of infants, varies in relation to nutrition, and for example, the suckling infant, which is fed with fresh breast milk, and we can see it in the column of mother own milk, has a significant abundance of bifidobacteria, which are highlighted in red, if compared to donor human milk fed infant. On the other hand, infant fed with formula present a different human milk gastrointestinal microbiome from both mother own milk and donor human milk fed infants. So donor human milk seems to favor an intestinal microbiome more similar to mother own milk than formula fed milk. I'm sorry, but I think there are problems with the slides. Which I'm not.
It might just be slightly slow because of the bandwidth.
Yeah, I think it's a problem of connection. Okay, I think it's the right slide. Okay.
Okay.
Also, this study is a reconfirmation of the differences which we have previously seen. And so, my question is how to improve the microbiome of pasteurized donor human milk. There are several strategies which could be used to promote and increase okay, there are some problem with the slides. I think it's the right slide, so I restart. Sorry, the first strategy I was saying should be that to promote and to increase the use of mother own milk in the neonatal intensive care. And even if small amounts of mother own milk are present, it could be very precious, these small amounts, because they would be added to donor human milk to personalize it from a microbiological point of view. And with regard to donor human milk, it could be useful to implement the pre-donation screening and the hygiene information of donors. But when formula is the only option, it could be integrated with probiotic bacteria isolated from human milk. And this could be a valid alternative. And lastly, in the future, the selection and the characterization of bacteria isolated from human milk could allow the design of a bacterial core of human milk, which is representative of an healthy microbiome and which could be specifically adapted to this target population. So what have we done to improve the microbiome of pasteurized donor human milk? We decided to study the feasibility of an inoculation strategy. And so, together with colleagues of the National Council of Research, we decided to evaluate the effect of fresh preterm mother milk inoculation into pasteurized donor human milk, and we evaluated both the bacterial growth and the diversity, the bacterial diversity. Always problem with slide. I'm so sorry.
Do you need technical to take over the slide deck, or I think it's just because it's a little bit slow, it's just on a delay.
Yeah, I think my slides are slowly, but I think it's due to problem of internet connection from my PC. So I was saying, I think this should be the right slide. I was saying that we have performed an in vitro study inoculating 10 samples of fresh preterm milk into pasteurized donor human milk, and we use a percent volume of inoculum of 10%. I mean, 10 ml of preterm milk into 19 ml of pasteurized donor human milk. Inoculated samples, which we will call EM samples, were incubated at 37 degrees for a time of 4 hours. We performed microbiological and also metataxonomic analysis, and they were conducted on preterm milk and pasteurized donor human milk at the baseline. So I mean before the inoculum at T0. And then at T1, so after 2 hours of inoculum, and T2, so 4 hours after inoculum, also on inoculated milk and on pasteurized donor human milk. Do you see the slide? So this was the study design I've just explained to you, but I think it's arrived just now.
Yes, can you please repeat the last sentence, Chiara? We didn't hear you.
Okay. In this slide is shown the study design. So I repeat, this was an in vitro study. We inoculate 10 samples of fresh preterm milk, which is called PM, into pasteurized donor human milk with a percent of inoculum of 10%. So I mean 10 ml of preterm milk into 19 ml of pasteurized donor human milk. And then inoculated samples, which we will call EM, were incubated at 37 degrees for 4 hours. A microbiological and metataxonomic analysis were conducted on preterm milk and pasteurized donor human milk at baseline, so at T0. And on inoculated milk and pasteurized donor human milk at 2 hours after the inoculum and at 4 hours after the inoculum. This was the study design. In this other slide, do you see the other slide, the next slide?
Yes, we see it.
Okay. Okay, in this slide I presented the results of the microbiological analysis, and so you can see the total bacterial count of preterm milk and inoculated milk sample. I haven't shown the data about pasteurized donor human milk because they did not change, the total bacterial count did not change throughout the time. What can we say? Among the TM preterm milk samples, which are in red, we can see a great intervariability. And that demonstrates a microbial diversity between individuals. With regard to inoculated milk samples, both at T1 and T2, but especially at T2, even if the 10 EM samples exhibit different growth evolution, we can say that at T2, which is in dark blue, they all showed a total bacterial count which is not significantly different from those of a preterm milk sample, and this could mean safety for us. In this other one slide, but I think you do not see it. Do you see the slide with the metataxonomic analysis?
Yes.
Yes, yes, we do. Thank you.
Okay, okay. In this slide, I presented, as I was saying, the results of the metataxonomic analysis performed at the baseline. So the analysis was performed on pasteurized donor human milk and on preterm milk before the inoculum. We can say with regard to preterm milk that the firmicutes are the most represented taxa, covering the 70%. It is followed by actinobacteria, which are in light blue, and then proteobacteria. In pasteurized donor human milk, instead, the proteobacteria is the more represented taxa. In the table on the right, I hope you can see it. You can see the different bacterial species, which are grouped as pathogens, hygiene indicators, lactic bacteria, and others. In this other slide, okay, it's here, I presented the results of the metataxonomic analysis at T2. So after 4 hours of incubation after the inoculum. And so we can see pasteurized human milk and inoculated milk expressed as a relative abundances. As you can see on the right, after 4 hours of inoculum, firmicutes, sorry, you can see, do you see the slide? I think no.
Yes, we can see the slide.
Okay, it is the slide of metataxonomic analysis.
Yes.
Okay, because I can see it. Okay. I was saying, okay, it's okay. As you can see, so here on the right, after 4 hours of inoculum, the firmicutes, so the blue area, are restored in the inoculum milk, inoculated milk samples. And with regard to pasteurized donor human milk, also in this case, we have not seen any variation from a metataxonomic point of view during all the time of incubation. But special attention should be paid to the lactobacilli, which are lactic bacteria. They belong to the phylum of firmicutes. And as we can see, they are present in all preterm milk and also in all inoculated milk samples at T2. You can say that in the inoculated milk samples at the T2, so 4 hours after the inoculum, the concentration of lactobacilli is slightly reduced if compared to the starting concentration of preterm milk. And it could be due to the dilution which was operated throughout the inoculus. But why lactobacilli are important. Lactobacilli are commonly present in human milk, and their role is to modulate the immunity, protecting against infections. There are some strains of lactobacilli which are metabolically active in the intestine of the newborn. So they produce functional metabolites which are crucial in terms of modulation of the intestinal function. And there are other strains which have been demonstrated in vitro instead to have a bacteriostatic and bactericidal effect against some pathogens. So in conclusion, what can we say? We can say that the addition of a little amount of premature fresh mother milk to pasteurized donor human milk can partially restore its microbiome, making it more similar to that of the breast milk. Secondly, so we can say that a personalization of the human milk microbiome seems to be possible, and this could be useful for premature infants given the presence of probiotic bacteria. But the feasibility of this inoculation strategy needs to be reinforced by further studies, not only in terms of numerosity, but also in terms of percent of volume inoculated in order to possibly transfer this strategy into the clinical practice. So I think you don't see the take-home messages slide.
Yes, we can see that. Slide? Yes.
Do you hear me?
Hello, yes, we can hear you.
Okay.
We can hear you and we can see your take-home slide. Yes.
This is the... Okay, perfectly. I'm so sorry. This is my last slide with the take-home messages. And so I would like to thank you all for your attention and all my colleagues.
Thank you very much indeed for that informative presentation, Dr. Tabasso. I know you've mentioned in the chat that you have to go to another call. So yeah, if there are any questions, we will follow those up with you directly. But thank you very much. I really appreciate it. So yeah, we're just slightly over time. Just want to conclude just to say
thank you so much.
Just to say thank you on behalf of MBEM and behalf of Medela. We thank you all for joining our webinar on this topic. I want to thank all of the speakers, Dr. Mook, Dr. Marquez, and Dr. Tabasso, for your talks. And you can see on this final slide here, we have another webinar coming up, which is on the 15th of November 2022. And you can see the topic here on the slide. If you're interested, there's a QR code there to scan, or you can find the information on both of our websites. And yeah, last but not least, and finally, I will give the final word to Dr. Bertino. Before I do that, was just one quick mention. Professor Rossellina has mentioned that her quality improvement work is going to be published very soon in next month's issue of Infant. The last word to you, Dr. Bertino. Thank you. I think you're on mute.
Yes, unmuted. Okay, but I am very happy. Congratulations to everybody. We have listened to 3 different intriguing aspects of use of human milk in NICUs. The first aspect, very well connected, showed us as we learning about physiology is the basis to improve the possibility to help mothers to breastfeed even in very critical situation. The third is a very fascinating, showed us very fascinating data. Maybe they will open new perspective to personalized pasteurized donor human milk that is a challenge in every NICUs. Anyway, I think that this webinar was not only directed to neonatologists, but also to pediatricians, to obstetricians, and also to medical practitioners. So don't forget next webinar in November. Thank you again to Medela. Thank you also to Dr. Moro, that was one of the sounds of these webinars. And thank you to everybody who was listening us.
Thank you very much indeed, everybody, and we wish you a good day, and we hope to see you soon at our next webinar. And finally, if you have any questions, our email address is here on the final slide. If you want any follow-ups from the webinar, please do get in touch with us over at Medical Affairs in Team Europe. Bye bye.
Bye bye.